Now let us see how to solve some gas law problems using Boyle's law, Charles' law, Avogadro's law, ideal gas law, and Dalton's law of partial pressure. Let's begin with the Boyle's law. As we mentioned in the previous lesson, the pressure and volume are inversely related. So the formula will be P1 V1 equal P2 V2 when you compare two gases or when you change the pressure and volume of the same gas, and temperature will be constant. So let us try a quick example here, a review. So here it is given the volume is 300 milliliter under a pressure of 720 millimeter mercury at constant temperature. If the pressure is increased to 800 millimeter mercury, what volume will the gas occupy? Here I can see there are two pressure values given. So I will take one of them as P1. So if I'm taking this one as P1 because that corresponds to the volume here. So 300 milliliter. So this is the volume and this is the pressure. And I will consider this one as V1 and this one as P1 because that goes together. And if the pressure is increased to 800 millimeter mercury, so I will consider this one as P2 and they're asking the volume when the pressure is increased. So I will calculate V2. So the given, we have V1, we have P1, we have P2, and the unknown is V2. And here, and then I will check the units. The units of P1 and P2 are same, so I don't have to convert anything. So I will just substitute in the formula, which is P1 V1 equal P2 V2. When you substitute, 720 times 300 equal 800 times V2. We can solve for V2 by taking 800 off from this side by dividing 800 on both sides. So when you solve it, you will get like this, which is 270. And what unit you will put depends on what unit given in the question. So here in the question it is milliliter. So the answer we are getting is also in milliliter. So let's move on to some practical application of Boyle's law. This is an example of breathing. So in breathing is, you can see that diaphragm contract and expand depends on the pressure. So that is an example of Boyle's law. Another example here is the deep sea fish die when brought to the surface. So here we can see again the Boyle's law. Okay, pressure and volume relationship. So, and now let us move on to Charles's law. In Charles's law, volume and temperature are directly related. So when you change volume or temperature of the sample of gases, and when you want to find one or the other, the formula we use will be V1 over T1 equal V2 over T2. So let us see an example for that. A gas occupies a volume of 473 centimeter cube. So centimeter cube is a unit for volume, and that gas has a temperature of 36 degrees Celsius. Here the point is that degree Celsius we have to convert it into Kelvin. So 36 plus 273 will be 306 Kelvin. And in the question, what will be the volume of the gas when the temperature is raised to 94 degrees Celsius? So I have to convert that 94 into Kelvin, and the unknown is the volume. Now let us substitute in the formula V1 over T1 equal V2 over T2. So when you substitute, and you can solve it just by cross multiplication, correct? So when you solve it, you will get 567 centimeter cube. That is the unit given in the question for V1. So we will put that unit here as well. So another practical application, a football is inflated inside and then taken outdoor on a winter day. What happens to the volume of the ball once outside? What law supports this? So definitely the volume decreases, correct? It's a winter day. So when the temperature decreases, the volume decreases. So Definitely, you know that's a Charles law application. Moving on to Gay-Lussac's law, which relates pressure and temperature when volume and number of moles are constant. So we can connect using the formula P1 over T1 equal P2 over T2. An example, a gas has a pressure of 80 millimeter mercury at 600 Kelvin. What pressure will the gas have at 150 Kelvin if the volume does not change? So the formula we will use is P1 over T1 equal P2 over T2. So we will first write what are the given variables, and then we will see what is it asking, and then we will just substitute in the formula. As usual, we just solve it. All right, so you can see that P2 is 20 millimeter mercury. The unit is coming from the question. So which unit you will put depends on the question, right? And also here, both are in Kelvin, so we don't have to convert the temperature unit here. Good. And now the Avogadro's law. If the pressure and temperature remains constant, then the relationship is the volume and the number of moles are directly proportional. So the plot will be a linear line, so linear graph when the volume and the number of moles are plotted. So V1 over N1 equal V2 over N2. And one example is here, suppose 5 liters of a gas is known to contain 0.965 moles. If the amount of gas is increased to 1.80 mole, what new volume will result? At an unchanged temperature and pressure. That means temperature and pressure is constant. So we will write all the given variables. We will write which is unknown, and we will check whether the units are okay with the same variable, and then we will proceed to substitute in the formula, and we will get, by just simplifying that one, the cross multiplication, you will get that volume to 9.3, and I will decide what unit I have to put by looking at the given volume in the question. All right, I hope these are simple. You already practiced in your labs, correct? And you did the homework questions and the quiz questions. So just take as a quick review, okay? So if you still have some trouble, let me know before the test. This is our ideal gas. It's ideal means it's a hypothetical substance. The word ideal means perfect. Gases that obey certain criteria behave ideally, which is, we can say, very low pressure and high temperature gases behave ideally. So the ideal gas law is used whenever the moles or grams is mentioned in the problem. So what P stands for here is the pressure, what V stands for here is volume, and T is nothing but temperature in Kelvin scale, and R is called universal gas constant. You can see the values from your reference material. Okay, so 0.0821 liter atmosphere mole Kelvin. That little x is multiplication. So liter atmosphere mole Kelvin is the unit we are using. Okay, and depends on the volume unit given, pressure unit given, and of course temperature should be in Kelvin. So N is the number of moles. So in other words, PV equal nRT. That is the normal form we write. So but the number of moles you can calculate by rearranging PV equal nRT, and that will look like this. So the ideal gas law is used whenever moles or grams is mentioned in the problem, because you can convert, if the grams is given, you can convert grams to moles. Okay, so if they're asking for grams, if you know the moles and if you know the compound, you can convert moles to grams and grams to moles. Okay, that we have practiced before. So let's see an example here, very quick example. A rigid steel cylinder with a volume of 20 liters is filled with a nitrogen gas to a final pressure of 200 atmospheric pressure at 27 degrees Celsius. How many moles of nitrogen gas does the cylinder contain? So it is asking for the number of moles. So pressure is given, temperature we had to convert it into Kelvin. What else is given? The volume is given, 20 liters. So we will use our unknown is the number of moles, and we will use our PV equal nRT formula, ideal gas formula, which is N equal, rearrange to N equal PV over RT and substitute. R is 0.0821, and then when you substitute, you can easily calculate number of moles. Okay, just simplify that. 200 times 20 divided by 0.0821 times 300 will give you the answer. All right. Another question here. When a rigid hollow sphere contains 680 liters of helium gas, which is heated to 600 Kelvin, the pressure of the gas increases to 18 atmosphere. How many grams of helium does the sphere contain? Say now it is asking about mass, grams. So first we can calculate the number of moles. So before that, let us write down what are the things given. Volume is given, temperature is given, pressure is given, and they're asking moles of helium converted to grams of helium. So that means they're asking grams, but first we will do the moles, then we will find the mass. So as usual, the formula is N equal PV over RT, and then R is 0.0821, substitute and simplify. So once you have that number of moles, you can simply calculate the mass by taking the molar mass of helium. In each 1 mole, we have 4 grams. So when you multiply moles with the molar mass, you will get the mass, because you already know moles equal mass over molar mass. Correct? All right.